See now the topic is polymeric surfactants. Also we can call it surface active polymers. See these polymeric surfactants are two types. Number one is block type. See one block of hydrophilic polymer, another block of lipophilic polymer is there in case of block type. But in case of graft type, see one layer of lipophilic polymer, that is to that lipophilic polymer we can add hydrophilic polymers perpendicularly. So what are the examples of this hydrophilic monomer? Nothing but polyoxyethylene. What are the examples of this lipophilic polymer? Is lipophilic monomer, that is polyoxypropylene. See these surfactants can be used as a dispersion. Next one is wetting agent and also used as a detergents. See examples of graft type polymers are carbomer. See this carbomer also we can call as a carbopol, that is the brand name of carbomer. This is a polyacrylate. This is water soluble. See how it is water soluble means due to the presence of hydrophilic group, that is carboxylic acid. Next one is polyvinyl alcohol, that is also water soluble. How it is water soluble means due to the presence of hydroxy group. Hydroxy group is water soluble. This is also example of graphite type polymer. Next, polyvinyl chloride, that is water insoluble in nature. See the chloride group is there, that is completely insoluble in water, hence it is water insoluble polymer. Next one is polyvinyl pyrrolidine. This polyvinyl pyrrolidine also we can call as a brand name, that is povidone. See this is water soluble. How it is water soluble means due to the presence of ketone group and amine. To the pyrrole group there is a presence of ketone group, hence this polyvinyl pyrrolidine or povidone will act as a water soluble graft type polymer. Next one is carbopol, as we have discussed at the first only. Next, carboxymethyl cellulose. See this carboxymethyl cellulose is also water soluble due to the presence of anionic function group, that is carboxylate anion. This is also water soluble. Next one is hydroxypropyl methyl cellulose. Also we can call it a ipromilose, HPMC. See this is water soluble in nature. How it is water soluble means, see this is the basic structure of hydroxypropyl methyl cellulose. See, hydroxy group and propyl group. This is the methyl group. Hence we can call it hydroxypropyl methyl cellulose. This hydroxypropyl methyl cellulose is water soluble due to the presence of hydroxy group. Next one is methyl cellulose. This is water soluble. So why this is water soluble means due to the presence of only single carbon atom like this. But ethyl cellulose is water insoluble. How it is water insoluble means, see the oxygen that can easily solubilize one carbon atom, but here the oxygen is there that cannot solubilize two carbon atom, that is ethyl groups. Hence, ethyl cellulose is water insoluble in nature. See the water soluble polymers have different uses in the pharmacy. The first and foremost thing is the hydrophilic polymers, water soluble polymers that will form flexible film. It will form flexible film around the tablet. If you want to coat the tablet, then it will form a flexible film. Next one is the same hydrophilic polymer, water soluble polymers will act as a fragmentating agent. See, this is a polymer that can form bridge between one solid particle and another solid particle. It will form bridges between the two solid particles. Next one is the same hydrophilic polymers will act as a emulsifying agent. How it is acts as a emulsifying agent means, see this is the oil droplet. These are the oil droplet dispersed in the water system. See, surrounding to this oil droplet, the polymers can form multimolecular film. See, this is the first, second, third, like that multimolecular film can be formed around the oil globule. Hence, this hydrophilic polymers used to stabilize the oil in water kind of system, but we cannot use it for the stability of water in oil kind of system. See, these hydrophilic polymers can be used as a binder. See how this will be used as a binder means. See, this is a one excipient, that is active pharmaceutical ingredient. See, this is a diluent, this is a sweetening agent, this is a coloring agent. See, if we have added a binder, that will form liquid bridges between the two excipients, and thereby it will act as a binder. Means it will bind to the different particles or excipients present in the granule. Hence, the hydrophilic polymers will act as a binder by forming the hydrogen bonding. Next, the same hydrophilic polymers will act as a binder and disintegrate. See, if the hydrophilic polymers are in open chain form like this, open chain form, then it will act as a binder. Means it will bound to the one excipient and another excipient. Like that, it will bound to the different kinds of excipient. That is open chain. If cross-linking of the polymers, see, these are we can call it a cross-linking. See, if the cross-linking of the polymers are there, then the hydrophilic polymers will act as a disintegrant. What is the difference between binder and disintegrant means the open chain hydrophilic polymers will act as a binder, but the cross-linked polymers, hydrophilic polymers will act as a disintegrants. See how these cross-linked disintegrants will act as a these cross-linked polymers, hydrophilic polymers acts as a disintegrant means see this is a tablet. This is a tablet that contains disintegrant. This cross-linked polymers act as a disintegrant and that contain different excipients. One, two, three, four. Four kind of excipients are there. When we have taken the tablet into the stomach, then what will happen means this polymer will absorb the water. From the GIT, the water will enter into the polymer. Then swelling of the polymers will take place. When the polymer will get swelled, see here the volume of the polymer is small, but here the volume of the polymer is get increased. The swelling of the polymers will happen. Once the swelling will be there, then slowly the particles will move outside. The part the particles or the excipients will move outside. Hence, these water-soluble polymers, cross-linked polymers will act as a disintegrants. So what are the examples of these water-soluble polymers are carbomer, also we can call it a carbopol, sodium carboxymethyl cellulose, acacia, tragacanth, alginates, dextran, polyvinyl pyrrolidine, and polyethylene glycol. All these are comes under water-soluble polymers. Very important. Next one is water insoluble polymers. See where we can use this water insoluble polymers means for the sustained release dosage form. If you want to develop the novel drug delivery system, definitely we need to use the water insoluble polymer. How it will act means, see this is a hydrophilic polymer, L nothing but lipophilic polymers. We have given coating of both this mixture of this hydrophilic and lipophilic polymer that will form a film around the tablet. This is a tablet. Around the tablet there is a formation of film. Once there is a formation of film, once we have taken this tablet into the stomach, then what will happen? This hydrophilic polymers, whatever this hydrophilic polymer is there, that can be dissolved in the stomach. Once the hydrophilic polymer is get dissolved, then slowly whatever the particles or excipients present in the tablet, that will be slowly or active ingredient that will be moved slowly like that. Hence, this will be water insoluble polymers can be acts as a sustained release dosage form. Next, the same water insoluble polymers only acts as the enteric polymers. See how it is acts as the enteric polymers means the pH dependent solubility of the polymers. So at stomach, see this is a polymer. This is a polymer layer surrounding to the tablet. That polymer contain acidic group. Like at stomach, the pH of the stomach is pH is 3. That is acidic pH. If we have given the acidic polymers, Acidic polymers nothing but cellulose acetate phthalate hydroxypropyl methyl cellulose phthalate. Means phthalic acid containing polymers will act as enteric polymers. If we have dissolved this tablet, if we have given this tablet into the stomach, then what will happen? In the stomach, the acidic groups are not at all get ionized. When it will enters into the intestine region, whatever these acidic polymers are get ionized, acidic groups are get ionized. Then slowly dissolving of these polymers will be there. Once the polymers are get dissolved here, then slowly release of the drug from that particular formulation will take place. Hence, water insoluble polymers. Hence, water insoluble polymers will act as the enteric polymers and also used for the sustained release novel drug delivery system. See, these are the different kinds of polymers can be used. That is polyethylene. This N indicates more number or N number of monomers. See, this is the structure of polyethylene. Next one is this is the structure of polypropylene. Propylene nothing but 3 carbon, 1, 2, 3 carbon. Next, polyvinyl alcohol. See, only this is the structure of polyvinyl alcohol. This is structure of polyvinyl alcohol that is water soluble in nature. Next one is carbomer. Carbopol as we have already discussed. Okay. Next one is polymethyl. See this is a methyl group, methyl meth acrylate, meth acrylate. This is the structure of this polymethyl methacrylate, polymethacrylate. Also we can call it hydrazine. Also we can call it a hydrazine. Next one is polyacrylamide. Like the difference polyethylene glycol. See, this is the basic structure of polyethylene glycol. This is the basic structure of polypropylene oxide. Just you can just know about these polymers and their basic structures. Polyvinyl pyrrolidine, some of these already we have discussed. Next one is miscellaneous surfactants. Under the miscellaneous surfactants, the non-ionic surfactant that is Poloxamer, very important. Pluronic or Poloxamer. What is the HLB value of pluronic or Poloxamer? All they have asked in the GPAT. See, this is used as a solubilizing agent, especially in case of parenterals. See, this pluronic or Poloxamer, it is a kind of block polymers. Under the graph polymers, we have discussed different types. Next, this under the black polymers, this pluronic will come. See, one block of A, another block, lipophilic B, again hydrophilic A. Like that, this is a black polymer. This hydrophilic is monomer unit is polyoxyethylene. Polyoxypropylene is example of water insoluble monomer units or lipophilic units. So this is the basic structure. See, polyoxyethylene, like that, this is the basic structure of pluronic or Poloxamer. Next one is polyethylene glycols. Also, we can call it a PEG. The brand name of polyethylene glycols are macrogols. See, this is a CN, nothing but polyethylene. See, this is a 2 carbon containing ethylene glycols. Polyethylene glycols means this is a OH, this is also OH. We can call it glycols. See, these polyethylene glycols, also we can call it macrogols. See, this PEG, after PEG, if any digits will be there, it simply indicates the molecular weight of that particular polyethylene glycols might. See, for example, here polyethylene glycol less than 600, nothing but polyethylene glycol that contains molecular weight less than 600 will be liquid in nature. So this polyethylene glycol less than 600 that will be acts as a humectants. 2009 GPAT MCQ. This is Polyethylene glycol 600 less than 600 will act as a humectant. See how it is act as a humectant, nothing but this will retain or it will retain the water molecule in the osmotic formulation. See how it will retain the water molecules means by forming the hydrogen bond. See, this is a polyethylene glycol basic structure. How this is a water moiety. This is a water moiety. How it will retain the water means, or how it will catches the water means by forming the hydrogen bond. Hydrogen bond between oxygen and hydrogen, hydrogen and oxygen, and hydrogen and oxygen. Like that, it will form hydrogen bond. Thereby, it will retain the water in the cosmetic preparations. The polyethylene glycol molecular weight is 600 to 1000. It is semi-solid in nature, used as a ointment or suppository base. If the polyethylene glycol molecular weight is greater than 1000, it is solid in nature. We can use it as a lubricant in case of tablets. This is about polyethylene glycols. Next one is fatty acid esters. See some of the fatty acids. See the surfactants also acts as a suppository base. For example, if you can take cocoa butter, cocoa butter and theobromine. See this cocoa butter and theobromine that is triglyceride in nature. See tri means one, two, three. Three fatty acids are there, and this is a glycerol moiety. Three carbon containing alcohol that is glycerol. We can call it a triglyceride. Cocoa butter is a triglyceride. If the first is contain oleic acid, second one is palmitic acid, third one is stearic acid. See this oleic acid is unsaturated fatty acid means between the two carbon there is a double bond will be there. Because of this double bond, the cocoa butter will shows different kinds of disadvantages. This oleic acid is unsaturated fatty acid responsible for the rancidity. For the rancidity of this cocoa butter and polymorphism also exhibited by this oleic acid and low shrinking property in case of mold. While the preparation of suppository bases, this shows low shrinking property in the mold. See, like that, the surfactants, this is, see, this triglyceride also a kind of surfactant. How it is means, see, all these groups are hydrophilic groups. Okay, this is lipophilic group. All the fatty acids are lipophilic in nature. Like that, it contains both lipophilic and hydrophilic moieties, hence it acts as a surfactants. These surfactants used as a suppository basis in case of suppositories. So this is about surfactants, polymeric surfactants.